This lecture will cover molarity. Some things that you're going to want to have before you get started. Make sure you have a periodic table. Be sure that you have your objective sheet, and you also want to have a calculator. So before we talk about what molarity is, we need to talk about solutions. So up until this point, we have talked about things that are solid because we've been talking about grams of a substance, which implies that it is in solid form. But that's not always going to happen. A lot of times we're going to have some of our compounds in a solution. So we need to know what the parts of a solution are before we can even talk about what these numbers are going to mean. So the first part of a solution is the solute. This is what is getting dissolved. So typically we would think of this as being the solid that dissolves into your liquid. And then the second part of your solution is the solvent. And this is what is doing the dissolving, what is making that solute dissolve into the liquid. So let's talk about an example, though, that we're all pretty familiar with. So I'm sure almost every single one of you has made Kool-Aid, or you've seen someone make Kool-Aid. So what do you need for that? You need the packet and you need the water. So thinking about that, the solute, what is being dissolved, is going to be what? The actual Kool-Aid powder, or the flavoring, or the sugar. So you may even add sugar to your Kool-Aid, which is going to give you an additional solute in that solution. So then your solvent is water. Now, just a general rule of thumb, anytime you see water within a solution, water is going to be your solvent. Water is considered a universal solvent. So anytime you see that, water is your solvent, and then whatever else is going to be your solute in that solution. All right. So now that we understand a solution and there's two parts, something's dissolving, something's being dissolved, something is doing the dissolving, now we'll go into molarity. So molarity, it's the measurement of how much solute there is to the solvent. And the units on that are going to be the moles of the solute per the liters of solution. Now, this is very important. Our solute must be in moles, so if you're given it in grams, you need to convert it into moles. And our solvent, for example, our water, must be in liters. If it's given to you in milliliters, you need to convert it into liters. So you want to make sure that those units are what you have. Okay, so it's very important, because if we change that up, we don't have the definition of molarity. So it's moles per liter. So it's moles per liter. All right. So you're going to see a few different types of problems. One of the easiest is when you're just finding the molarity of the solution. So you are given, in this problem, we're asking for the molarity of a 2.5 liter solution with 0.621 moles of magnesium sulfate. Now, in this, it really doesn't even matter that this is magnesium sulfate, because our molarity is just based off the number of moles and the liters of the solvent. So we could have this as magnesium sulfate, this could be potassium sulfate, it could be sodium sulfide. There's so many options, but your molarity is going to be the same because your moles and liters are the same. Now, if this were grams and we needed to use the molar mass, then your compound does matter, okay? So now this is a simple math problem where you're going to take your 0.621 moles and you're going to divide that by 2.5 liters. And that gives you 0.248. And actually, we'll look at sig figs. This should be 0.25. And our units are a capital M And that capital M stands for molar. So we would say that this is a 2.5 molar solution. So your unit on that, your abbreviation is going to be a capital M. Remember, a lowercase m would represent meters, and that wouldn't even make sense in this situation. So be sure that you're using your correct unit for your answer. So 0.25 capital M or 0.25 molar. So easy enough. It's just a simple division, making sure that you have the correct units on these. All right, so that's just finding the molarity, but there are 3 variables in this. So kind of think density equals mass times volume type thing, where I could have asked you the density, I could ask you the mass, I could ask you the volume. Same thing here. I could ask you for the volume, so your liters, or I could ask you for the moles. So this question here, how many moles of lithium fluoride would be required to produce a 2.5 molar solution with a volume of 1.5 liters? Now, what I want you to think about is that this unit of something being 2.5 molar really means that you have 2.5 moles per 1 liter. Now, what does that look like? This now looks like a conversion factor. So we're going to use that molarity as a conversion factor instead of what we're starting with, okay? What we are going to use here, we're going to start with our volume that we're given. So we'll start with 1.5 liters, and then we're going to use this as our conversion factor. So to get liters to cancel, that needs to stay on the bottom. So we have 2.5 moles and then 1 liter. And now my units of liters are going to cancel. So now we're going to go ahead and do our math here. So 1.5 times 2.5 should give you 3.75 moles of lithium fluoride. Now I could continue, ask you another question. How many grams would this be? And then you would just need to convert these moles into grams, which you should be pretty proficient at doing that now. So the key here is using that molarity as a conversion factor that will allow your units, like the units of liters here, to cancel. All right, so how many grams of calcium hydroxide are needed to produce 500 milliliters of a 0.166 molar calcium hydroxide solution? Well, very similar to what we saw before. So we're going to take our molarity unit and we're going to draw it out into its separate units. This is moles per 1 liter. So we are given our starting 500 milliliters is our solvent, and we're looking for grams of calcium hydroxide, which is our solute. So start with what you know. We know we have 500 milliliters. So this should already be raising a red flag, because what do we need our units to be in? We need our units to be in liters. So we need to get these milliliters into liters here. Now you can start off, you can just move your decimal over, which is fine. Or you can just do it this way. 1,000 milliliters is 1 liter. And now we're in liters, so we need to use this conversion factor. Now, this can also be written as this. 1 liter is 1.66 moles. So remember when you were doing your molar mass, when you're doing your stoichiometry, you can flip your grams and flip your moles and flip your molecules. It's the same thing here. It's just an equivalent statement or a conversion factor, so you can flip them because they're equal. So we need for liters to be on the bottom, which it's already set up that way, but if we needed to, we could have flipped it to this way. 1.66 moles, 1 liter. Now we're in moles, but we want grams. So to go from moles of calcium hydroxide to grams, we need to find out our molar mass, which I've already done for you. 74.04 grams per mole. We need moles to cancel, so that 74.04 is going to go on top. Per 1 mole. And really, I don't have enough room, but right here you do want to have that's grams of calcium hydroxide, just so we can keep track of our units. All right, checking out to see if our units cancel: milliliters, milliliters, liters, liters, moles, moles, and we're going to be left with grams. So if you go through and do the math on that, you're going to get 61.45 grams of CaOH2. So in order for us to have a 1.66 molar solution, if we have 500 milliliters of our solvent, we need 61.45 grams of our solute, which is calcium hydroxide. All right, so some things for you to remember. Moles, 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 moles. Have to be in moles. If it gives you grams, got to convert. Next thing, need to be in liters. You're given milliliters, convert into liters. You're given kiloliters, convert into liters. So you might want to take a look at your metric conversions. Remember, King Henry died by drinking chocolate milk. So you can move your decimal, or you can provide a conversion factor for that. So capital M is your unit for molarity, not a lowercase m, and we call that molar. And we're using molarity as your conversion factor. We're not going to start with it. And then also remember that 6 molar equals 6 moles per 1 liter, which is the same thing as 1 liter per 6 moles. You can use those interchangeably so you can have your units cancel. So there is another lecture on dilutions. You're going to want to watch that as well, because both of those parts are on the same quiz. So go ahead, try some practice molarity problems, and then you can move on to dilutions. Let me know if you have any problems.